I'm going to define the equation of a straight line. So here, example 1 says find the equation of a straight line with m equals -2 and c equals 7. Well, we know the straight line rule. Y equals mx plus c. Oops. Mx plus c. We know the gradient here. So we've got y equals, the gradient is -2, and we've got the x next to it. And we know that c is plus 7. So there's the equation of this straight line. Example 2 says find the equation of the straight line with gradient -2. And there's our m. And it passes through this point right here, -3a. So again, I'm just going to write the rule. Y equals mx plus c. I'm going to fill in what I know. And I do know that this is my x part and this is my y part. So using x and y and the gradient, I will be able to find my c. So I've got 8 equals, my gradient is -2 times, my x is -3 plus my c. That's why they give us that, to help us find our c. So I get 8 equals, I'm able to work this out, -2 times -3 gives me +6. And then to find my c, I have to get rid of that +6, so it becomes -6. It's gone from here. And I get c equals 8 minus 6 is 2. Therefore, my rule is y equals, and remember, y equals mx plus c. So we get y equals, our gradient is -2, they give us that, so -2x, and my c is +2. The example 3, find the equation of the straight line. This time it gives us the y-intercept of -4, and it tells us that it passes through that. So again, let's use y equals mx plus c. This point here again is my x and my y. So I've got 8, and this is going to help us find the gradient, equals m, but x is 1, so 1 times my m, don't need to write the 1 there, plus c, oops, c is -4, so that should be -4. So I get 8 equals 1 times m, that's just m, -4, and got to get rid of that to find my m, becomes +4. So I get m equals 8 plus 4 gives me 12. So now I know my gradient, I know my y-intercept, so I get y equals mx plus c. I get y equals m is 12, so 12x, and c was -4. So that's that rule there. You can use a different rule, equation of the line with 2 given points. We can use this rule over here, y minus y1 equals mx minus x1. Of course, the gradient is still that rule there. And that's when they give us 2 points only, like example 4, find the equation of the straight line passing through these 2 points. Well, we'll need to find the gradient first. So we already know how to find the gradient, so I'm just going to do it over here. M equals y2 minus y1. You can see I write the rules all the time. x2 minus x1. I'm not going to label them, but my second point is 1 and 2, and my first point is -2 and 3. So y2 is 2 minus my y1 is +3. There they are there. And then my x1 is x2 is 1, and my take away my x1 is -2, and a negative becomes a +2. So I end up getting 2 minus 3 is -1, and 1 plus 2 is 3. So -1/3. Now we use that, and we can use this one here, or we can even use the other one. I'm going to use this one just to make it different for you. So y minus y1 equals mx minus x1. Doesn't matter which point I use, I'm going to use the point 1, 2, and I know that my gradient equals -1/3. So I get y minus 2 equals -1/3 x minus 1. expand to the brackets, I get y minus 2 equals negative x over 3, and a third times 1 gives me positive third. Add the 2 to get rid of it, so I get negative a third x. That comes there, becomes plus 2 as a fraction. 2 is 6 divided by 3, because we've got to get the same thing so we can add them. So this becomes 7/3. And that's probably the best way to leave it. You can times everything by 3, and if you times everything by 3, you get 3y will equal negative x plus 7. We should try and get rid of the denominators if we can. Example 5. Find the equation of a straight line. This time it passes through this point here, and it has the gradient over here. So we can use the y minus y1, and I'm going to use that one because I've done enough with the other one. But it doesn't matter which one you used, I won't mark you wrong. The point that I have is 2 and 3, so y minus 3 equals the gradient is negative 3, x minus 2, and expand the brackets again, so y minus 3 equals, expanding this times the negative 3 by everything, remember, so minus 3x, and minus 3 times minus 2 becomes positive, and 3 2s are 6, and now to get rid of this one, we add the 3 to the other side. That cancels there. We get y equals negative 3x, and 6 plus 3 gives me 9. So we found that equation. Example 6, find the equation of the line shown in this graph. Now again, I'm just going to use the rise over run to quickly work out the gradient. So I've got 6 over 3. It's a negative gradient, I know that because the graph's going downhill. So negative 6 divided by 3, and 6 divided by 3 is negative 2. And then, it doesn't matter which one I'm going to use out of the points. I have 2 points here, 3 and 0, and 0, 6. I'm going to use 3 and 0, and I'm just going to use y equals mx plus c. Actually, I won't use the 3, 0. I'm going to use the 0, 6, because the 0, 6 means it's the y-intercept. So I've got y equals negative 2x, and the y-intercept is positive 6. So that's easy to do like that. This one here, what is the equation of the line shown in the graph? Well, this one is y equals 3, because it goes all along the y equals 3 line. This one here is at x equals 2, and x equals 2 for all the values irrelevant y equals, so that's our line. And that is exercise 2C.